we have a problem here on determination of percentage purity. So we are given a sample which is Rochelle salt, and it is titrated with sulfuric acid. So you have here in the titrant, which is sulfuric acid, and the analyte is our sample, which is the Rochelle salt, or I simply place there RS, which weighs 0.95 grams. So when was titrated, the volume used is 43.65. However, endpoint is overrun. So you need to back titrate it with sodium hydroxide. That is why there is a volume here of 1.72 since this was overstepped. Okay, so you need to back titrate it with sodium hydroxide in order to get the desired endpoint. So which is 1.72. So that is the volume for sodium hydroxide. There is another data here which was from previous analysis, in which you have here a concentration ratio of 1 ml of sulfuric acid is equivalent to 0.1321 normal sodium hydroxide with a volume of 1.064 ml. What would be the percentage purity? Okay, so again we make use of the formula milliequivalence of the acid is equal to milliequivalence of the base. In solving the percentage purity, that would be equal to milliequivalence of the Rochelle salt is equal to the milliequivalence of sulfuric acid minus the milliequivalence of sodium hydroxide used in titration. However, we do not know the normality of sulfuric acid, but we can compute it by using this concentration ratio. So we make use of this formula first. Milliequivalence of sulfuric acid is equal to milliequivalence of sodium hydroxide. Substituting the values, we do not know the normality of sulfuric acid times the volume used in this, which is 1 ml, is equal to the normality, which is 0.1321 normal of sodium hydroxide times the volume, which is 1.064 ml. So the unit for normality is milliequivalence per ml. So the ml and ml will cancel and you have here a milliequivalence. So normality of sulfuric acid would be equal to 0.1406 normal. So we can now use this data in solving for the percentage purity. Okay, now we make use of this formula again. Milliequivalence of the base is equal to milliequivalence of the acid. We have two bases here, sodium hydroxide and the Rochelle salt. This sodium hydroxide was used for back titration because there was an excess. This was overrun or overstep for the endpoint. The endpoint was overrun. So there was an excess, so we have to back titrate it with sodium hydroxide. Weight of Rochelle salt is unknown, so we do not know the weight of Rochelle salt. So we're going to solve for this. In order to take note that the percentage purity would be equal to weight of the substance divided by weight of the sample times 100. So substituting the values now, or you can write plus the sodium hydroxide on this side. However, if you're going to place the sodium hydroxide here, that would be minus already. So minus the milliequivalence of sodium hydroxide. I just wrote the sodium hydroxide here so that you will see the difference between the base and the acid. Okay. So weight of Rochelle salt now is unknown. Molecular weight of Rochelle salt, which is equal to 282.83 grams per mole divided by the factor. So Rochelle salt has a formula of potassium sodium tartrate. So C4, if you're going H4O6, C4H4O6, and you have here tetrahydrate. Okay, so take note that we have here a base. So what would be the factor? potassium and sodium. So the factor would be 2 equivalents per mole times 1,000 plus normality of sodium hydroxide, which is given 0.1321 normal, multiply it with the volume, which is used for the back titration, 1.72 ml. Okay, is equal to the normality of sulfuric acid, which we have solved previously, 0.1406 normal, times the volume used in for titration is 43.65 ml. So you will get here a value of Rochelle salt in grams, which is equal to 0.834 grams. Percentage purity is equal to weight of the substance, which is Rochelle salt, divided by weight of the sample times 100. So just substitute 0.834 grams divided by weight of the sample, which is 0.95 grams, times 100. And you will get here a percentage purity of 87.79%. Or you can make use of the formula in your module. So you can use it directly. Percentage of the component. So take note, would be the normality of sulfuric acid times the volume. So milliequivalents of sulfuric acid minus milliequivalents of this, times you're going to multiply it with the molecular weight times 1 divided by the factor times 1,000 times the weight of the sample.